Hello everyone, I'm Xiaogang. Let's first start up and run a simple test. We can't send this message yet, right? Because we haven't written the sending method yet. Let's take it step by step. First, we ensure it can receive the message. That way, you'll have a method to check if the code you wrote earlier has any omissions or issues, making it easier for us to continue writing. Okay, let's wait for it to start. Okay, we've started it up now. Let's not rush to write this UI for now, because this UI is actually quite troublesome to write. Let's create a sewer level here. We'll do some related work in the level blueprint. Okay, we've opened this level now. We need to access our subsystem now. It should be XG. Let's take a look at the subsystem. Let's see if we can extract it. Because I've already written a lot of these subsystems, it should be this one. Then we have several delegates to bind here. Right. Actually, we probably don't need to bind this delegate for now. For now, we don't really need to bind this delegate. We'll mainly just let it start directly, because we might have some processes that haven't been completed yet. Okay, as for this start, let's give it port 9083. Then let's print a log here. If it succeeds, he should be able to pull this up successfully. Okay, good. Okay, let's start it here. Start Wedge fake server. Okay, you can see it should have been successfully opened here. Then we'll just enter one here. Localhost. Let's see how it should be written. Localhost 1983. Let's try it. Let's see how this thing works. Then you will find, if we input here, this URL and the link are not quite working, then it will tell you that the connection failed. And how was this thing created? Actually, you click here where it says Neo. Let me take a screenshot of this so we don't have to later. Here we create a with check. Then we just press connect. The connection is not successful now. You can see, right? And actually, if you start it here, let's set a breakpoint. We found that this thing is not activated, right? Let's turn it off. Actually, why is it not activated? We'll reveal the reason for this later. And you can see here, we connect again. It is in the connecting state. It cannot successfully establish an electrical connection. Our breakpoints here are also not being hit. So what is causing this? What is the cause? Actually, it's very simple. Because we missed something here. Because in fact, this thing needs to manually tick it. So we need to determine now if our server is running. So we let our Weibo says the server needs to be manually ticked. This is a very common problem. Why is that? Why is that? Because this thing might need us to manually tick it. Yes, many engine modules require ticking. Because it processes frame by frame. There is a small point here. That is, everyone should not. If your network requirements are high, you better not rely on these engine features. Because all these engine things are completely, in other words, we call it embedded into the main loop of the engine. So if you do a lot of ticks in there, the pressure is particularly high, especially for network sending and receiving information. But we are not pursuing high performance here. And our amount of information is not large. It's not big either, probably just between a few servers. A function like this, so we have no problem. Then we prepare a method here called the TickServer, the connection of TickServer, because all our connections also need to tick. We'll write this connection first. We put it down here, put it below. Then this link is actually to iterate through our entire this entire line. Then here we get what we currently have. We first prepare an HYE first. If we currently have any timeouts, we first iterate through our map. We let it tick first. Just let it tick on its own. Then we check if there are any timeouts. If there is a timeout, we change its status to the timeout. Then we set this out of time rewarding. We'll treat it as equivalent to save it. After saving, we need to handle this direction. This timeout situation, for this kind of timeout, We think this kind of thing should be directly released. A tangent this kind of thing should. So in our underlying release interface, we directly take the timed out GUID and release it directly. Because if it times out, we consider it disconnected. We'll directly reclaim the resource for you. So that's the situation. Now that we have added this tick, actually, right here, at this point, this tick, we need to take what we just wrote, called TickServerConnection. Let me call it. Okay, good. After writing it like this, we start our project. We perform a simple test. This time it should correctly. After our startup is complete, enter this endpoint. After entering this endpoint, then we will proceed to the next step. Enter the sending and receiving of this information. This endpoint when our this here. Okay. Now let's start it. It's already started. Then at this point, we connect again. We connect again. Hey, you can see the exercise has come in. This is correct and complete. This means our wishats has been successfully created. We need to set up the binding proxy. When this side has been successfully created, I'll remove the exercise. Otherwise, the exercise time will be too long. It might cause errors. You can see that information has been received here. Look, this side is already showing green. Then we send a message here. It will definitely report an error. Because this has not been Base64 encoded, it has already been sent here. Actually, right? Then here, we should have a miss. Let's take a look at what's going on with this message. This is a bit troublesome. Let's start. We need to act quickly because there is a mechanism underneath. You can see. Right, we have connected successfully. We just send it casually. This side will receive this message. Let's make it pause for a moment. You will find here, you can see, it cannot parse this abbreviation. It considers it invalid. So why are we sending a message now? It's no longer useful. You can see it. It's because this place is already timed out. Timed out. Our server has actually closed it. So actually here, you can send this message. So if you want to send this message, we can do a Base64 encoding here. Let's just do something simple. Then the encoded message should probably look like this. I remember ours should be. We can take a look. Let's copy this over. This is a bit troublesome because we started the heartbeat early here. So we need to release it in advance. So if you act quickly, you can still send this message. Once we finish writing this, there won't be this problem. Then for the step, let's check. We mainly have these fields. There's code in this matrix. As for this matrix, we really don't know what it will look like after serialization. Then let's just write something random for now. Let's try to pull this field over. Okay. I already got it working on my E4. Let's give everyone a thumbs up and demonstrate. Let's start, then we connect. Then we send. You will see, we have already received it on our end, but it says error here. You don't need to worry about that because why is it an error? It's because of what we wrote in this code. You see, in our code, if this code equals 0, it will be normal. If it is wrong, this place will report an error. So this place is correct. That is, we have no parsing error. So how should this be written? We taught you earlier. This is how you write it, right? But I tried it. I didn't strictly follow that writing. Writing it this way allows it to be parsed. Then there is a type here. We mainly look at this type. These fields correspond to it. Then you need to check the convert node in UE. Just see what the conversion result looks like. Then we set this to -1 here. So it is a field. Let's change it to 0 first. So when you write the convert node, you need to set up this because you might make a mistake here. Because if, for example, you add a semicolon here, it won't be a convert node anymore. So we need to align this part. We'll change this to 0. We'll set it to 0. Then we give it a Base64 encoding. After the encoding is complete, after it's done, then we copy it over here. After copying it over, we need to restart here because we have a heartbeat. I forgot to turn it off. Let's move quickly. It's starting up here. Then we establish a connection. After establishing the connection, we send it directly. You can see we don't have this here. The one above is illegal. You can see this side is normal. We have already received this data. You can see, basically, we have successfully run through this process for everyone. Sending it like this now definitely won't work. Why won't it work? Because we have already released it. Because you exceeded 3 seconds. Because you did not activate our heartbeat mechanism. So how do we activate the heartbeat mechanism? We haven't written it yet. After we finish defining the server port, we will write the heartbeat for everyone on the client side. Because for a server like this, actually, this communication information is defined by ourselves. So, you can only test it simply. You can't fully use Postman to write it because sometimes there is encryption or some messy parameters. you need to make some settings in these places. So it's especially troublesome. You can see that the connection is successful here. It has some version information provided by Weber, some header information, some other information. If you have these needs, you might need to study it further, okay? So we've got the process running for everyone here. There are a few segments here, mainly to review for everyone. Right here, remember to tick it here. You must tick this place. This tick will cause us, if we don't refresh this connection status, it will be recycled after 3 seconds. Then we need to let the client maintain the status of this connection. We need to do a heartbeat. Okay, then we'll do that later. So that concludes this lesson. Thank you everyone.